symbols that we have for today, because we're going to be doing both of these in the notes, and you will be addressing both in your homework. So the first thing we're going to be making sure we concentrate on is being able to classify polynomials and write them in standard form. Okay? And then the other one is I can evaluate polynomial expressions. Well, you really have already been working with polynomials all along. We just weren't calling them that. So polynomials is really not a new thing. It's something that we've already been doing. You've been doing it you were doing it back in elementary school. And maybe just not, we were just calling them expressions at that point, or terms, or something like that, rather than polynomials. So let's take a colored pencil, and let's first of all talk about what the first type of polynomial called a monomial. So let's circle the word monomial in here. A monomial, well, when you hear the prefix mono, what does that say to you? One, yeah. A monomial. So we're going to have it's a one-term polynomial is what it is. And this one-term polynomial can be, let's underline this, a number, a variable, or a product of number and variables with whole number exponents. So whatever color you're using, just stay with that color to identify what a monomial is. So your age, if I asked you to state your age, that number would be considered a monomial. If we take your age times something, a variable, make it 15x, it's still a monomial. It's a product then of a number and a variable. And then notice what it says, and whole number exponents. So not something to a rational exponent, not something to a negative exponent, only to a whole number exponent, and the whole number start at 0 and go up by ones in the positive direction. So a monomial. When I say monomial, you need to think, she is talking about a one-term polynomial. Okay, now grab another color. A polynomial, let's put a box around that one. A monomial is actually a polynomial. Okay, a monomial is a polynomial. But a polynomial is made up of monomials. So a polynomial is a monomial or a sum or difference of them. So there can be, in a polynomial, there can just be a monomial, one term, or there can be the sum or difference, an addition or subtraction of monomials. Notice in a monomial, there is no addition or subtraction going on. Only a product, it says, a multiplication. So in a monomial, there's only multiplication and or division, because division can be rewritten as multiplication. When we have a polynomial, we can have a monomial, where there's no addition or subtraction, or we can have other monomials being added or subtracted from it or to it, okay? So those are really important that we have an understanding of. A polynomial is a monomial or a sum or difference of monomials. Okay, now let's go back to whatever color you use for monomial. Let's go back to that color. And let's do the degree of a monomial. The degree of a monomial. So if they ask you what's the degree of this monomial, how are you going to find it? You're going to add the exponents together, the sum of the exponents. So you're going to look at every exponent on a variable. On a variable. So if there are no variables in it, then we're going to have to say, well, then what would I consider it to be? But you're going to add up all of the exponents in the monomial. Okay, so let's look at this monomial that's here first. It says, find the degree of 8x squared y cubed. Let's circle that with that color as you have in your hand right now. 8x squared y cubed. If they ask you for the degree of that monomial, now notice it's a monomial because there's no addition or subtraction going on in it. Only multiplication. 8 times x squared times y cubed. There's no addition or subtraction. One term. It's a monomial. So when we're asked to find the degree, we're going to look at the exponents on the variable terms only. Only the variable parts, the variable factors. So we have an x squared, we have a y cubed, the exponents are 2 and 3. So we would say that the degree is 5. 2 plus 3, this is a degree 5 monomial. A degree 5. In our other one over here, we have another monomial, -4, a to the 6th b. So we look at the variable factors in our monomial, and we say, what are the exponents on the variables? We have a 6 and an invisible 1 on that b. So we add those together, and we say that the degree of this one is 7. 6 plus 1, 7. It's a degree 7 monomial. Okay, let's grab the color that you use for polynomial now. Grab the color you use for polynomial. Go back to that one. We're going to talk about the degree of a polynomial because you've got to keep this straight. When we talk about degrees of polynomials, we're going to do something just a little bit different, but it's really what we were just practicing. We're going to find the degree of the term, whichever monomial in that polynomial has the greatest degree, that becomes the degree of the whole polynomial. It takes over and says, I am the degree of the polynomial. I am the monomial term with the largest degree. So here's our first one. 2x to the 4th, y to the 3rd, plus 9x to the 5th. It is a two-term polynomial. That's two terms, one being added to the other, two monomials being added together. So it's a two-term polynomial. The degree of the first one is 7, because 4 plus 3. The degree of the second one is 5 because there's only one variable factor in that one, and it's to the 5th degree. So the 7 is larger than the 5, so we would say the degree of our polynomial is 7. We don't add the 7 and the 5 together. The monomial term that is the largest takes over and says, I get to claim the degree of the polynomial. So same thing here. We have the 4ab plus 9a cubed. Again, we have a two-term, two monomials being added together. We have a degree 2 monomial. We have a degree 3 monomial. We don't add them together. We say 3 is larger than 2, so the degree of the polynomial is going to be 3. So maybe the way to think of it is whenever I'm finding degree, I'm always finding the degree of a monomial. And when there's more than one monomial, I need to take the one that has the largest degree. So any questions on, first of all, what I'm talking about when I say monomial, polynomial, and degrees? Before we move on, it's important that we know how to identify those. Okay, pick a new color. Because now we're going to talk about the standard form of a polynomial. So, I don't know, I guess I'll go back to circling here. Standard form of a polynomial. It's important that we know how to write a polynomial in standard form. There'll be lots of reasons why it's important coming up. Right now we need to know how to do it. So when I ask you to put a polynomial in standard form, what you're going to do is you're going to write it with the terms in order from greatest degree to least degree. Remember, we just talked about those degrees. So the monomials are going to be lined up from largest degree to smallest degree. And then we have another thing we have to talk about. Let's put a box around this one, leading coefficient. A polynomial also has a leading coefficient. Anybody know what a coefficient means? Okay, so it's a number that something is being multiplied by in an expression, though, not an equation. So we have this expression, we have this monomial term, the number up front that those variable parts are being multiplied by are called the coefficient. So we have, here's our polynomial right here that we're going to be talking about. We have 5x squared plus 6x cubed plus 4 plus 2x to the 4th, and we're supposed to write that in standard form. First of all, tell me how many monomials are there in that polynomial? How many are there? 4. Yeah. There's 4 monomials making up that polynomial. We need to put those monomials in order from greatest degree to least degree. So see how they've identified the degrees underneath here? The first one has 5x has degree 1, 6x cubed is degree 3. Notice this one. When you have just a number, no variable part, it's degree 0. Anybody think they know why that would be? Why would we consider just a constant, a number, to be a degree 0. Let me remind you, we get the degree from the variable parts. Are there any variable parts? Well, what if I wanted you to write 4 as a monomial with a variable part? What if I wanted to put an x there? Can I just do that? Is it still degree 0? No, what is it now? Degree 1. Could I do this? Is 4x to the 0 power the same as 4?
Maybe.
No, it's 1. Oh wait, yeah.
Maybe.
Maybe.
As long as x is not 0.
If x is not 0, that's where the maybe comes in. If x is not 0, what is x to the 0 power? 1. What's 1 times 4? 4. So in reality, there's this invisible x to the 0 power there. So the degree is 0. So the degree of this number term, this constant term, is 0. And then the degree of the last one is 4. So what do? We rearrange them so that the one with the largest degree comes first. So that's 2x to the 4th power, except there's a problem here. I see a mistake. 2x to the 4th power is being subtracted. So what does that make, that 2x to the 4th power? Negative, doesn't it? So we need to put a negative sign in front of that. We need a negative sign in front of that 2x to the 4th power. Because 2x to the 4th was being subtracted, which we can't have subtraction in our polynomials. And then the next one is our 3rd degree one, the next one is our 1st degree, and notice what's last. And we should probably always be last, is the number term, or the constant term, if there is one. So now we can say this is in standard form. Let's put that. This is standard form. Negative 2x to the 4th plus 6x cubed plus 5x plus 4 can be considered to be in standard form. And they have to all be in their correct location. You can't have a couple of them mixed up and say, well, it was close. They need to all be in their correct location in their order of degree. And notice what they say, the leading coefficient, let's put a box around that, the leading coefficient is 2. But what are we going to change it to? Do you think it's really 2? What is it? Negative 2. Yeah, it's a negative 2. So we got to stick a negative sign in there. That's a negative 2x to the 4th. X to the 4th is being multiplied by a negative 2. That's its coefficient. So the leading coefficient is always what is the first monomial's coefficient. What is its being multiplied by? That becomes the leading coefficient of the whole polynomial. Okay, can somebody tell me what the degree of this polynomial is then? What's the degree of that polynomial that we just put in standard form? What would it be? Remember, go up above. How do we describe the degree of a polynomial? It would be a degree 4, wouldn't it? Because whichever monomial has the greatest degree gets to claim the degree of the polynomial. Well, once it's in standard form, all you have to do is look at that first monomial and say, what's your degree? That's going to be the degree of the polynomial. So any questions on standard form, leading coefficients? Okay, now I guess we're ready to practice. Was that a hand-up question? Okay. Find the degree of each monomial. Okay, number 1. What's the degree of that monomial? 8. How did we get that? Add the 3 and the 5. So 3 plus 5, we're going to say it is a degree 8. Hey, now you're using your pencils. Go grab your own pencils now. Now we're done taking notes during the highlighting part. So put those colored pencils down and stop playing. Grab your own pencil to do this practice now. Okay, what's the degree of number 2? 6xyz. What's its degree? 3. Because we have x to the 1st power, y to the 1st power, z to the 1st power. And what would 6 be? What power is that to?
0.
To the 0 power, because what did we take the powers from? The variable parts. Well, there's really not a variable on 6, so we would say it's a degree 0. So we have degree 3 here. 1 plus 1 plus 1 is 3. Okay, and the last one, 4x squared, y squared. Aaron?
4x squared and y squared, it would be 4x squared plus what? Wouldn't it just be like that?
It'd be 4.
Five,
It's degree. Because that's 2 plus 2. 2 plus 2 is.
What do we do? Add the exponents on the variable part, so 2 plus 2, this is a degree 4. Okay. So we have a degree 4 monomial. All of those were monomials. They were all a product of a number and variables, and they don't have to have variables, but all of these did happen to have. Okay, how do we find the degree of polynomials then? What did we say again? Find the monomial term that has the greatest degree. So we're going to identify underneath what is the degree of that first term, that first monomial. 5, okay? What's the degree of the second monomial? 6. So what's the degree of our two-term polynomials? It is 6. We have a degree 6. Okay,
wait, why is that one 6?
Is y.
because we take, when there's more than one monomial, which we have 2 of them, don't we? We take the one that has the largest degree.
But the y doesn't have
Okay, what invisible power is there that they just didn't write?
1.
1.
So wouldn't that all in here?
So 5 plus 1 would be 6, wouldn't it? Okay, go ahead and do 5 and 6. Then you tell me what the degrees of each of those polynomials are. And be ready to tell me what the degree of each monomial in the polynomial is. Okay, what's the degree of number 5, that polynomial?
4.
4? 5? Okay, well, the degree of the first monomial is what? 5. The degree of the second monomial is 4. The degree of the last polynomial or the monomial is? No, it's 0. That's the part that's confusing. It is 7 to the first power. It is 7 to the first power. But when we're looking for the degrees, and we're looking at the exponents on the variable parts. So what variable part could be attached to 7?
1.
X to the 0 power, or y to the 0 power. Any variable you want to the 0 power. So this one is really a degree 0, not a degree 1. The variable is the one, the exponent on the variable part is the one that helps us identify it.
It could be where x would be 1, and then maybe,
Because notice what didn't we do in that first monomial where we had 4x squared y cubed? Did we worry about it that it's 4 to the first power? Did we add 1 to 2 and to 3 and say that's a degree 6 monomial? No, we said it's a degree 5 because we only worry about the variables and their exponents. Okay, so that is a degree 5, and that's the largest degree, so our polynomial is a degree 5. How about the last one? What is it? Degree 2. Yeah, it just so happens that 2 of them have, 2 of the monomials have a degree 2, so they, I guess, get to have a tie there. It's a degree 2. Okay. So any questions yet on degree? Seems a little confusing for some of us. Okay, then let's go to standard form then, because we're still going to be working with degree. Write the polynomial in standard form. Okay, well the first thing I want you to do is I want you to take each of these monomials and I want you to identify what their degrees are. So the degree of x cubed is what? 3. The degree of 5x to the 4th is 4. The degree of negative, well actually those are negative, negative 6x to the 5th is 5. Okay, and now when we want it in standard form, we put them in, we order those monomials from largest degree to smallest degree. So what's this one going to start out like? Negative 6x to the 5th. What's next? Minus 5x to the 4th. And last? Plus, this is a positive, so we can use addition here, plus x cubed. There is our polynomial in standard form. But notice what else do they want us to do? They want us then to give the leading coefficient. I'll let you call that LC, okay? LC is what? Negative 6. The first monomial's coefficient. So the leading coefficient of this polynomial is negative 6. So questions on that one? Okay. Go ahead and try those last two on your own then. Do what I said. Identify the degree of each monomial involved in the polynomial. Then reorder them so they go greatest to least. And then see if you can identify the leading coefficient. Okay, let's stop after you do number 8. And let's talk about that one first. Make sure we're doing it right before we attack number 9. Do you agree with standard form the way I have it?
Mm-hmm.
Negative x cubed plus 5x squared plus 2x. What's its leading coefficient then?
-1.
Negative 1. There's an invisible 1 between that negative sign and that x cubed, so our leading coefficient is negative 1. Okay? Okay, so what ended up, go ahead and finish up. You might not have gotten this one done yet.
7.
So, what's the standard form for it, first of all? How does standard form for that polynomial go?
7x squared
Plus 8x, okay?
minus 1.
Minus 1, okay? So there's our standard form. And what's its leading coefficient?
7.
7. Okay, now, if you don't put it in standard form correctly, are you going to probably get the leading coefficient wrong? Yes, because we always look to the first monomial to get our leading coefficient. So if you don't have the correct leading monomial, you're going to have the wrong leading coefficient, okay? Anything we need to clear up on this side before we move on to the back side? Okay, then let's go. Grab a colored pencil again. Okay, this is where the road meets the road. You really need to know how to name polynomials. This is classifying polynomials now, okay? So polynomials have special names, not all of them, but some of them have special names based on their degree and the number of terms they have. So let's first of all let's box this. Polynomials have special names. And I'm going to have you write up here though, not all of them. In other words, we might be kind of generic with their names. They have a name. We can still classify them, but they're not going to be special, really. Okay? And how we do it is on their degree and number of terms. That's really important. They have a 2-part name, just like, remember back when we were doing systems of linear inequalities, we said 3 of the systems had 2-part names. Well, that's how polynomials are classified also. They have 2-part names, all of them. None of them are without a middle name. So this is kind of like a chart that you need to get this memorized. You really do. You just need to know it. If it's a degree 0, we call it a constant. If it's a degree 1, we call it linear. If it's degree 2, we call it quadratic. If it's degree 3, we call it cubic. If it's degree 4, we call it quartic, because there's 4 quarts in a gallon. If it's degree 5, we call it quintic. And anything starting at 6th degree doesn't have any special name. We now call it a 6th degree or a 7th degree or an 8th degree and so on. Okay? So that's the degree name. Then they have a term name. So if they have, according to how many monomials basically are in the polynomial. So if there's only one monomial in the polynomial, it's called a monomial. If there's 2, it's called a what? If there's 2 monomials in a polynomial, it's called binomial. If there's 3, it's called trinomial. If it's 4, it's called polynomial. Anything 4 terms, 4 monomials and above doesn't have a special name. Okay, so let's just take a really quick look at this one right here. Let's put a box around this one. We're classifying it according to its degree and number of terms. Well, first of all, you want to make sure it's in standard form so that you can identify its degree. Is that one in standard form, 7x to the 4th plus 5x plus 3? How do you feel about that? You think it's in standard form? Okay. So what is its degree? What's its degree? It's a degree 4, so right here, put an underline in that. It's a degree 4 because 7x to the 4th power is a degree 4. And how many monomials are there involved? There are 3, 1, 2, 3, so we say it has 3 terms. Now we decide what its name is. And they've already done it for us. They say it is a quartic trinomial. Quartic why? Because it's a 4th degree. Trinomial why? Because it has 3 terms. Okay, let's just jump down and go do some classifying before we do the evaluating polynomials. So, what do you think? Number 10. And you have to write this down for me, okay? In your homework, this is important. I want you to do this. I want you to write degree, terms, and then you can give its name. You have to write this. So go back to your pencil for now. Go back to your regular pencil. We're practicing. What degree is this one? It's a degree 2. Okay. Is it in standard form, by the way? Yeah, okay. How many terms are there? How many monomial parts are there? 2. Okay. So it's a 2nd degree, 2 term. What are we going to call it? Okay. And typically what they do is they start with a degree name. Okay. So degree. So the degree makes it a, what did you say? Quadratic. That's different than quartic, and we need to be able to spell. I do not know how you guys cannot spell properly when the words are somewhere right on the paper for you to copy. Quadratic, 2, 2nd degree, binomial, because there are 2 terms. And we need to know how to spell these correctly also. Binomial. They all end in nomial. It's just their prefix that's different. It's either mono or bi or tri, okay? Or poly. Okay, go ahead and you identify. Do what you think I'm going to expect in your homework for number 11. What do you have to do and then give its 2-part name? Reminder, don't just automatically look at the first term and say that's going to be the degree of the polynomial unless it is in standard form. The only time you can say, oh, this is the degree of the polynomial is the first term's degree. Is when it is in standard form. It's the only time you can get away with that. Okay, so what's its degree? 3. Is it in standard form, by the way? 3, 2, 1, and this would actually be b to the 0 power. It looks to me like it's in standard form. 3, 2, 1, 0. It's going from greatest degree down to least degree. How many terms are there? 4. Okay. Degree 3? Cubic. Terms for polynomial. There's not a special type of name, so we use the polynomial name. Cubic polynomial. So questions on that one at all? Okay, now let's go back up and do our last thing that we're going to do, which was our other objective today, being able to classify, or evaluate, I mean. So you know what, this kind of runs into that up there, so I want you to make a point that this is its own section, okay? Polynomials can be evaluated. So in this one, we have this ball that's being thrown straight up in the air from a height of 4 feet at 65 feet per second. You know what? You really don't have to worry about a height of 4 feet at a speed of 65 feet per second, because guess what? That's taken care of in the polynomial itself. They've taken the liberty to put those in where they need to be in the polynomial. The height of the ball is given by that polynomial, negative 16t squared plus 65t plus 4, where t is time in seconds. How high is the ball after 2 seconds? So notice what they did. They put 2 in for t. In both places there was t in the polynomial. We have to follow order of operations. Order of operations says do exponents first, and then, so we got 4 from that, and then go back and multiply. And in this one, we can see after all of the order of operations has been followed in doing the arithmetic, we end up with 70, which tells us then that after 2 seconds, the ball is 70 feet high. And we are going to answer these in sentence form like this. So maybe you should put a box around that, how to answer exclamation point. After 2 seconds, the ball is 70 feet high. Okay, let's go grab your other pencil again now. Let's go practice this one. We have this time we have the ball being thrown straight up in the air, but from a height of 6 feet and at a speed of 80 feet per second. So notice right here, why don't you circle in here what our polynomial is that represents that. We have a negative 16t squared plus 80t. There's our speed right there. And from a height of 6 feet plus 6. So let's write that one down here, because we're going to use it. And we're going to substitute into it. T is time in seconds again. We're supposed to find the height of the ball after 3 seconds. Let's put over here, t equals 3. So in other words, we're evaluating that polynomial for t equals 3. It can be evaluated for any time amount. It could be for 1.5 seconds. It could be for 9 3/4 seconds. We're doing it for 3 seconds. So we're going to substitute in, and if you want to grab a colored pencil to do the substituting, you can. But we're going to substitute in where the t's are a 3. So substitution step. Don't try to shortchange these and do too much in one step. Okay? What do we do first in that first monomial? Negative 16 times 3 squared. What do we do first? 3 times 2? 3 times 3, or in other words, 3 squared. So we're going to have negative 16 now times what? Times 9. We can do this multiplication now, can't we? 80 times 3 is 240. And then we have our plus 6. Okay, negative 16 times 9. Well, let's see. Negative 16 times 10 is negative 160, but I went 1 too many 16 times. So what would negative 160 plus, negative 144 plus 16, negative 144 plus, can we add these two together? Does it matter which? Can we group 240 addition? Since it's all addition, okay, so 240 plus 6 is 246. And negative 144 plus 246, basically 246 take away 144.
102.
102. Positive or negative?
Positive.
Positive. So it evaluated to be 102. But we have to end this with a sentence. What are we going to say? After
3 seconds.
3 seconds. Okay. After capital A, after 3 seconds, because that's what we put in for T, after 3 seconds, the ball, this is a ball, right? Yep. The ball is 102, is it feet? Feet in the air. Or off the ground, or whatever you want to say. End of sentence punctuation. Okay. So questions on classifying, naming them. Questions on evaluating them. Okay, go ahead and get your colored pencils put back in the box then,